Hello, Honors Chemistry, and welcome to Chapter 6, Section 6.9, where we learn to go from an empirical to a molecular, right? So we learned back in Chapter 5, the definitions are empirical as this is our most reduced, right? Which then, if we think about what that means, right, this is the actual formula, which is typically a whole number multiple, right? Sometimes that multiple is 1, right? But, whatever it is, it must be a whole number multiple bigger, right? If for whatever reason you ever end up with some math that tells you it's not a whole number multiple, you did something wrong, right? So use that as a telltale sign to reconsider your steps along the way, right? So if we think about what this means, if CH is my empirical and this is my molecular, right? Because if I reduced my 6's, right, divide them both by 6, I'd end up at CH, right? Now, if I multiply my atoms by 6, clearly that means my mass would multiply by 6, right? So if I take my CH and I add one C and one H, I'm going to end up at 13.02 grams per mole, right? If I look at my C6H6, I get 78.12, right, grams per mole, right? And you'll see that this is also an order of 6 times bigger, right? Because if I multiply the atoms by 6, I would multiply the mass by 6, right? And that's going to be our way to figure out the relationship, right? Because if I know the mass of my molecular formula and I know the mass of my empirical, I can take my 78.12, divide it by 13.02, and that's going to give me my multiplier, right, to figure out the relationship. Yes? Does that make sense? All right, let's go ahead and solve some. All right, so if my empirical formula is C2H5 and the molar mass of my molecule is 58.12, right? If it doesn't otherwise say, we're talking about the molecule, right? Find its molecular formula. So I'm going to take my 58.12 because that's my molecule, and I'm going to divide it by the molar mass of this, which is 2 carbons and 5 hydrogens. And I will see that this is a multiplier of 2, right? Which means I'm going to take C2H5 times 2, which is going to give me C4H10, and that is the molecular formula for butane, right? Those little canisters that you plug into those small portable camping grills, right? Which is different than the propane that would be in your large backyard grills, right? So, depending on what you're using. All right. Molar mass of this, I shortcut the problem because I wanted it to fit on one line, right? Find the molecular formula if we know these things, right? So if the goal is to find the molecular formula, what's really the first step we need? Right. It doesn't tell you, but it's understood that you clearly need an empirical formula first, right? Now let's talk about our empirical formula. So it gives us percents, so we'll have to assume we have a 100-gram sample and then turn our percents into masses, right? Step 1. Then we'll go from mass to moles, then we'll reduce, and then we'll scale up as needed, okay? Now, don't forget that percents always sum to what? Right, they sum up to 100, right? Which means that let's say the problem we're being, thoughtful, and it excluded the mass of nitrogen, but it told you it was composed of carbon, hydrogen, and nitrogen. Could you find it for the percent of nitrogen? Yes, you could. It would just be 100 minus the carbon, minus the hydrogen, and whatever's left must be nitrogen, yes? Just something to tuck away and make sure you understand. All right, so let's go ahead and solve this. All right, grams to moles, and then we reduce, and then we have our empirical. Okay, so now we have an empirical formula. So now we are going to take my molecular, 60.10 grams per mole, which is the scaled up version or the actual version, and divide it by my empirical molar mass, which is 30.06, right, grams per mole, and clearly that is 2, a scaling factor of 2. So I'm going to get C2H8N2. Yes? Does that make sense? All right. Thank you for listening. Be good, and no worries. There is practice coming. All right. Thank you.